There's some pretty cool cutting-edge technology on this truck. The aerodynamics have been dramatically improved, the truck lightened, and the engine is way more efficient than an off-the-shelf engine. But there's another component here that made a big difference to the outcome, the road load management system. I'm Jim Park with today's Trucking's Ultimate Test Drive. We're in Denton, Texas, checking out the Cummins Peterbilt SuperTruck. In a way, the road load management system is art imitating life, or I should say technology imitating life. It's an advanced cruise control system that uses GPS along with terrain profiles of the road to help the truck negotiate hills, curves, and changes in speed limits. It operates the truck the same way a really good driver would. How does it work? Here's Peterbilt SuperTruck project engineer Bruce Besner. This is the road load management system.
Right.
Typical cruise control on steroids, I'm told. How does this work? What's the advantage?
Well, what it does, it reads the terrain ahead of the truck, and as you go downhill, it'll give more acceleration to get the momentum built up, and then as you're pulling the grade, it may slow you down a little bit so you don't waste the momentum that you've built up on the downhill grades. So it basically speeds up and slows down your vehicle to optimize your fuel performance. Say like if we're set at 64 miles an hour, it's got the route programmed into it, so it's programmed to get from point A to point B as if you was a standard cruise at that speed. So it takes that into consideration in the calculation. So it's going to maintain a speed to have the same arrival time, so that if you have a point of destination, you have a schedule to meet, you're not slowed down so much that you don't meet your schedule.
Okay, so when I set the cruise for 64 miles an hour,
yes, sir.
It's on a traditional cruise control system, the engine's going to try and maintain something close to 64 going up a hill.
Right.
This is not going to keep it at 64. It's going to drop down a few RPM to save fuel.
Right.
But ultimately calculate the trip time as being no different than it would be.
Yes, sir.
Okay. Because the road's profile has been loaded into the computer, the truck knows when it's approaching a hill or about to crest a hill. And since it's designed to minimize fuel consumption, it knows when to add power, when to reduce power, and when to idle, just like a really good driver.
This is that's how good drivers drive.
Yeah.
They'll set the cruise and then they'll feather the throttle a little bit, just to get a little momentum going downhill. And they might back off the cruise a mile an hour or two going uphill.
Yep.
And at the end of the day, they improve their fuel economy by 4 or 5%. But that amount of improvement, that puts you at the top of your company's drivers.
Yeah. With all the pressure on drivers to deliver on time, does it really make sense to slow the truck down when it should be powering up a hill? Is that going to add a lot of time to a trip?
Pretty small amount of change. We're just talking 2 or 3 miles per hour, but it makes a big impact on fuel economy. Like pulling the hill and topping the crest of the hill at 61 versus 64, you've taken a lot more energy to maintain that vehicle rolling at that, pulling that grade.
Yeah.
But then on the flip side of that, when you go down the hills and you gain the momentum, it takes very little input to really help your speed to pick up. And with that additional speed, now that momentum's going to carry you halfway up the hill before your engine even starts burning any fuel. The route we took to test the road load management system was the same one Peterbilt used during the test phase of the SuperTruck's development. We headed out west of Denton on Route 380 and then turned northwest onto a hilly section of Route 287. That took us through Bowie and Henrietta. There we turned east onto Highway 82, which ran back to Interstate 35, where we turned south back into Denton. The best stretch of road to put the road load management system through its paces was the hilly section of Route 287, and that's also where I got my biggest surprise of the day. You'll notice on this downgrade, it'll actually pick up speed if the traffic allows, and it's limited. You can put in parameters, so it doesn't allow the truck to overspeed, to actually, break the law. We were up to 75 coming down that little hill. Right, and the speed limit's on this road 75.
Oh, okay. Well, that was like hardly any hill. How did we get up so fast? Because this thing is so aerodynamic?
Yes.
Damn, what a difference.
It's slippery.
And this is where the big surprise came for me. On 3 or 4 occasions, I thought to myself, well, this system's obviously not working because the engine's obviously applying power because we're going down this hill way faster than we should be.
What it was lack of aerodynamic drag and lack of rolling resistance that was getting the vehicle speed up as quickly as it was.
Of course, the truck's vast reduction in rolling resistance and aerodynamic drag aren't about getting it going downhill faster, but that's a very effective way to demonstrate how drastic that reduction is. Here's the significance. It's been proven that it takes roughly 225 horsepower to overcome the normal rolling resistance and aerodynamic drag on a typical fully loaded truck running at 60 miles per hour on level ground. Bruce Besner and Ken Damon both claim that the SuperTruck requires significantly less horsepower to achieve that same result.
It takes, with all this aerodynamic treatment on the truck, about 140 horsepower to maintain this truck at a road speed of 65 miles per hour. 140 horsepower, that's 140. So the engine under this particular hood's a 450 horsepower Cummins. The question arises, do you need 450 horsepower? Well, clearly not at cruise speed, although there's lots of opportunity to use that horsepower for climbing hills and pulling headwinds and what have you, or even running heavier than this truck is usually loaded.
When you can reduce the power required to move a truck down the road to this degree, it opens the door to smaller and lighter 11 and 12-liter engines for some applications. Their lighter weight would further increase the freight efficiency and likely provide further improvements in fuel economy as well. Having said that, there are inherent fuel economy and operational benefits to the larger engines like the ISX-15, including the ability to operate at really low RPM while churning out tons of fuel-saving low-end torque. The design improvements we see here on the SuperTruck could play a seminal role in future truck designs. Of course, the real test for all this technology will be industry acceptance. Trucking is notoriously conservative and slow to embrace change. For that reason, US Express was asked to be the chief industry consultant on the project and to provide reality checks based on its vast real-world experience.
I don't think anything is easy. I think, as we've talked about, the industry is slow to change, and I think US Express, having been our advisors throughout this, the fact that we engineers are very creative people, but we're not the users, and the fact that we use them so extensively as our consultants, I think they see the opportunity and are going to be much more likely to be early adopters when it's available.
Not every feature on the SuperTruck will appeal to every truck buyer out there, but Ken Damon says US Express was pretty excited about what they saw. The fleet actually ran some revenue loads with the SuperTruck, and that led directly to the development of the retractable trailer fairings as well as the liftable door over the trailer tandems. The road load management system as well as the shift schedules Eaton brought to the 18-speed UltraShift automated transmission are good examples of how technology can replicate the techniques used for years by the best drivers in the business. The technology we see here can make the worst driver into the best driver with just the turn of a key. To learn more about what the engineers at Cummins and Peterbilt have come up with for this project, check out the other 3 videos in our SuperTruck series. Part 1 is an overview of the truck and the project, Part 2 dives deep into the technology under the hood and between the frame rails, and Part 4 highlights the truck's many aerodynamic enhancements. From Denton, Texas, I'm Jim Park for today's Trucking's Ultimate Test Drive Series. Drive safe and keep your revs down.